Okay, we're recording now.
Thank you.
So the author list will be stated specifically, and you'll be credited for the piece that you write. And you'll be on the first banner there. And you can choose to use your company affiliation or just writing as a professional expert. That's going to be up to you. Depends what politics you're dealt. But we're all in this group because of our intellect. And then the next line will be contributors and reviewers. So contributors and reviewers would be folks that want to do peer review of the paper. And then contributors would be you show up to the meetings and you engage. Your name will be on here as well. Okay. So it starts with the abstract. So far, the abstract's getting good reviews. Again, I'm not going to go because it's so long. I'm just going to kind of walk through. Introduction. Because of the complexity of the process, this process is not, it's temporal. It's not a linear left and flow process of data and projection and prediction and estimating flow. So what we decided, what the team decided internally here is we'll put a process map together. I was joking around. I called it the other day. I was joking around. We call it the electric mixer process. You know, when you buy an electric mixer, let's say, and you pull it out of the box, and you go, well, how do you turn the thing on? And you go to the schematic, and it will have, you know, where all of the pieces are. It has a schematic, a line with a number, you know,
like
or
a switch diagram.
What is it?
Yes.
Switch diagram or something.
A switch diagram. I
Electronic.
like mixer better.
I was having nightmares of circuits and
circuit. There you go. Circuit diagram.
Yeah,
That was it.
I was having old school flashbacks about those classes in college.
Yes, well, that's
circuitry.
That's essentially what it will be. But the reason that's important is because what it will do is it will ground everyone on the complexity of. Remember, we think with this process is thinking left, right, up, down, in, out, time, predictions, verifications, repredictions, things of that nature. So we have to think holistically, and I think the paper does a fairly good job, I believe, of getting us in that that mindset. So to keep everyone grounded, the readers. Many folks are analytical thinkers, but maybe not visual thinkers, and vice versa. So to keep grounding on both type of thinking, as we go through the paper, I'll be referring to various numbers in the key. So the reader can, when we have a section that is somewhat complex or whatever, they can look at the key and see where in the process the flow is. So just FYI, and then all the readers, all of the writers or authors would pretty much do the same thing. So that's being done. The next thing is that we're starting with vocabulary. There was discussion whether we put the vocabulary at the bottom, you know, as an appendix or in the front. We decided to go in the front. And the reason is because there's a lot of, we're thinking out of the box. There's a lot of new terms and things. And we feel that if it's at the end, folks won't read the terminology. So just getting things aligned as far as what we're calling things. And it's also categorized in different quadrants, as you can see here, structural components of estimating system and what have you. So you have kind of a meaning of what it's going. Then we go into the actual master estimating theory, how it applies to the process. And then that's broken down into various sections. And again, we'll release this here for review. We'll talk about that down the road. So I'm still developing, or we are still developing the visuals. This is, if you recall, one of the meetings we did a breakout of what a moon, this is the hypothetical scenario that Johns Hopkins Applied Physics Lab put together. Jabu Abraham, if you recall, did a nice presentation. Using that, we put kind of a downstream estimate together, and we'll use that as an illustration. We also have some linear examples of various things, so we're not always thinking in three-dimensional, but we have a practical thing too. And again, these are still being developed, but we're getting real close. Then we go into coding structure. I want to really emphasize something on this one. The coding structure is infinite. And I think the piece does a good job of explaining what the coding structure would be. We're building on the NASA 7 category coding structure, so we start with that, so it doesn't mess up anything that NASA has, because it's built on decades and decades of need. But it talks about all the other types of coding, and just for construction alone, we use CSI, master format, or uniformat, but we're also introducing OmniClass, which is the modeling, and it's more holistic and has more temporal things. We're also using a lifecycle and maintenance codes that will be developed, and each of these are separate systems. And again, I don't want to get too far in it, but I think it does a good job of laying that out. I'll just kind of keep going. We're making a premise that the verification and neural net that is receiving all the information is NASA's G2 process, which we've talked many times about, because it keeps all this in control of the owner, as opposed to that information just getting out of control and just getting out of control, essentially. But it talks about how we'd be rolling into that. And again, that's theoretical at this point. Estimating mathematics, just beyond, labor, material, equipment, things of that nature. We talk about predictive analytics and things of that nature. Dominant twin. So in the construction industry right now, in engineering, I'm sure we're all beginning to hear about the term model twin. And the estimate is in that category only. It's the dominant side of the twin. Usually when we talk about model twins, we think about just modeling. And you have one model, three-dimensional model, engineering model, and then another twin that is more of an experimentation. And we're using that same concept, but what will happen is the master estimate becomes it's a model twin of essentially everything. And so the master estimate is in literally control and know of every aspect of the project, or of the well, I guess you can, the venture, I guess, or we can say project. Okay, well, I'll just kind of keep going here, because it's just a read that you have to kind of get through. So far, the feedback I'm getting is that that surprisingly it's quite an easy read. That even though it's pretty deep, it reads well, and tends to be is tending to be a fun read, which is interesting. I thought it would be too complex. All right. So that's essentially the paper as far as the master theory. Now, look, this could have been another 14 pages, and And I think the realization, and we'll talk about that after we go, when 14 pages, that's just the master theory side of estimating, how it all ties together. And then we have 15 other authors that are writing small sections. So we're going to discuss how we're going to handle that. Look, this is a major complex challenge that we're trying to face. It is extremely challenging, and there's a lot at stake. And so this should not be, a small paper that doesn't lay out a very specific case from all angles and all lenses. It needs to be a compelling case, and that's what we've been working on for about a year and a half. Okay, so I'll just kind of keep going down here a little bit, and then I want to get to the next section. Okay, so here is still what needs to be done. Obviously the reviews are nothing major right now, but there are some changes that need to occur, and this I think would be distributed to authors like on Monday, so you can read through it and help shape your portion of the paper. Still to do. This is going to be more of a research paper and study paper. It's like a hybrid between research paper and a practical application, because remember, we are practitioners pushing into academia. We're practitioners that are solving a problem, as opposed to academia being theoretical and then seeing if it fits in the practical application. So it's something important to note. But through conversation, we still think it's extremely important to reference and indicate citations, because this is built on many foundations. It's a new way of thinking, obviously, but it's based on a tremendous amount of accepted and fundamental foundation. So that is a process that so far we've identified 20 to 25 crediting and citations that will be included. Okay. We're also developing figures, and because this is fairly complex, we want to make sure that the visual aspect of what's going on is maintained. Because there's a lot of abstract flow, how does one think, of data and analysis in 3 dimension? It's difficult sometimes, and some are think linearly, and some not. And as an example, I've been teaching for almost 20 years, and 18 of that has been adults in the industry, and through Davis here, and many of them are engineers. And then I teach in the engineering department now. I'm a practitioner, but I teach in engineering, and I'm always fascinated by some minds think very linear in function, and abstract sometimes is a challenge. Sometimes people think in abstract, not linear, and have trouble with analytical linear line of thinking. So we want to have this paper reach out to both types of thinking. All right. So what's next? So we have contributing editors. Now, the section 2.
Hey, Paul,
Yes.
I have a question. Just going back to that, like,
Please.
there's going to be, I'm sure, multiple groups that become the audience of this paper, like who it's intended for. But who is the primary audience, and what are we trying to achieve with them at the end of the day with this?
Yeah, I think the audience is going to be not primary. I think because I want to also back up, and I want to inform the group of something. I've been, for the last year and a half, I don't even know how many conferences. That's how I met Patrick.
Yeah.
He does a lot of conferences, and he's a very respected speaker in the industry. We met each other at a conference. Remember that, Patrick? You were chairing the conference, matter of fact. And you were in the audience when I was presenting this, but the conferences I do, it's analytical, estimating, pre-construction, that type of stuff. AI in pre-construction analysis, and so hundreds of folks have heard these concepts that this group has been working on for a year or so, and the excitement has been. I mean, we have 70 folks in this group right now. It started with 20, and it just keeps growing. So to your question, I'm getting a good sense of the excitement within the industry and the need. The need's definitely been. This is what we're doing. You're involved in a groundbreaking or a very unique. Filling a void, because we've done a lot of searches on this type of work, and there's just not a lot there. There's there's construction technology and material and maybe superficial estimating, but to go this deep, systemic way of estimating such a complex system is, this group is spearheading that. And doing it in a hybrid way between academia and in the industry. So back to your question, I think that our audience is going to be academia, and also I think obviously aerospace, but also the industry. So I think it's going to be like a big stew,
Yeah.
like a casserole.
Thank you.
Yeah. So what the exciting thing is this has been my main focus on all of the conferences that I've been doing, and it really has just been fascinating. Everyone's just so engaged and excited and intrigued, because we all have experiences about how we're here. So that's what grabbed us. All right, so let's talk about the author list, and I've talked to most of you already about this.
Well, can I ask one quick question? I'm sorry to interrupt.
Yeah, please.
When you say industry, are you talking about construction industry, or what industry are you talking about?
Construction industry, construction and design. Yeah.
Okay.
Thanks, Fred. That was obvious in my mind, but it wasn't obvious. So thank you.
Yeah.
Appreciate it.
Okay.
I'm sure you're going to find all sorts of stuff like that in my paper, or not my paper, in the paper. My apologies if I say my paper. That's a terrible habit, and I will get out of that, because obviously all of us have been contributing. All right. So here's the author list. Dr. Young Hung Kim, University of Louisville, is he's in the LISIC, very active member in LSIC group, and he'll be doing a piece in his field. We're talking about that, I believe, next week, and he's really anxious to contribute. Dr. Amir Savinci, he's teaches at Davis, but he's also a fascinating individual, very active in the industry, in the construction industry. He's also head project manager for the Port of LA, and he's very active in the industry. And he'll be doing it on integrated project delivery, estimate, interaction, and function in early technology construction and construction implementation. So in other words, using integrated project delivery that we're experimenting with massive construction projects here, and how do we integrate that into the aerospace industry. Next is Vishish, Dr. Vishish Singh, and he's already submitted his piece, which is subjective objective analysis and verification. Associate Dean at California State University, Fresno is Dr. Brad Hyatt. He's Army Corps of Engineer estimator in the Navy for many, many years, and also a practitioner in estimating. He's written a fascinating piece on coding and financial component tracking that's not tied to Steve's interest, well, of many things. Steve right here. Steve will be writing a piece on return on investment concepts. And Mark Hilberg would be, he's doing just a general topic. We haven't decided. It'll be more of a general term or general theme topic. Dr. John Harvey here at UC Davis, he is, and I notice here that my apologies. Let's see if this will fix it. Yeah, there we go. Dr. John Harvey, California Transportation Department, it's called Caltrans. He does essentially all the highways and roads. He wrote the specifications for, and he's very involved in Caltrans here in California. Well, he's developed, he and his team for years been using a theory that they've developed, which is a predictive way. It's very similar to like, strangely, we're at a conference about 6 months ago, and we started comparing notes, and we're like, wow, this is just so fascinating how, they're predicting how cracks form in our freeways, not only predicting where they're going to crack, but exactly what direction and how long. And and they use a verification predictability where it constantly changes, and also verification. It's fascinating. So he's writing a piece, taking his work and tying it into a mirror of how does the predictability and the verification instantly, how does that correlate. Dr. Jay Lunn is a probability expert, and he's written some fascinating work, many papers. He's also for the state of California water resource expert as well. But he's writing expanding on a paper that he wrote called The Risk of Risk Analysis. Patrick Duke, he's writing on procurements and risk analysis. Jennifer Taylor is with HDR, and her strength is molding or connecting, aligning general contractor, owner, architect. And HDR is a very large, they're international, and huge architectural firm. And so she has a really good sense of that. I've worked with her on a $4.5 billion hospital before, and she was magical at how she ties things together. She's writing a piece on cycle jumps of process in complex projects. So in other words, we have these large projects and all this complexity. How do we stop risk from transferring to all these different systems that have to work like a gear? It's a fascinating subject. Rivka has already submitted her paper, and we should get that out to review. And it's fascinating. It's understanding a set of parameters of measuring production site excavation for large-scale extreme projects. So what she's done is she's taken, and she's a CPE certified professional estimator with ASPE, is very well known, and also is a great writer. Her piece is absolutely fascinating, and it's what are the questions, what are the things that we have to consider even when they're inventing, as they're inventing the technology. How do we then move that into a production analysis and means and methods on very extreme things? And she's changed that into things that we're going to have to think about in estimating for excavation. And the reason this was important, and we talked about, we collaborated, and I had her write on this subject, is because I was at an LSIC conference one time, It was about a year ago, I think. And we're in a breakout group, and we're talking about the Caterpillar was there and what have you, and we're talking about the sheer amount of cubic yardage that's going to be moved. It's in the hundreds of thousands of
Wow.
cubic yards that they're predicting that they're going to be moved through, through the years or whatever. But it's so complex, because of the electrostatic and the corrosiveness, not the corrosiveness, but the how rigid and sharp, they're little microscopic shards, essentially, the regolith is. So anyway, fascinating paper, ties in great. Fred with Rudolph Slutton, again, a very large general contractor nationally. Fred used to be an estimator for NASA in the 80s, and he's again very well respected in estimating electrical systems and for complex projects as well. And he's writing a piece on downstream analysis qualifications and for estimating quantifications. I'm sorry, for estimating. So in other words, with little information, how do we come up with a process that we can expand and be in front of design so we're anticipating articulately what's coming down the and with high level of reliability. And remember, everything we're talking about always has a high level of reliability, or why. Scott Kuntz with Genco, he'll be writing a piece on what type of questions does an estimator ask early in design. So you're asking the right questions always, so you have a good breadth of understanding how the estimating is starting to shape up. And again, the estimate will be in front of engineering models and simulation models. The estimate will be in front of technology, actually. It has to be. Otherwise, you're always playing catch up. And this is what the paper goes over. So anyway, really fascinating subject. He's a great thinker in that field, so I'm looking forward to that. Colin Moore is with an international company called Haskell Construction, and he heads up the prefabrication division of Haskell, and he'll be estimating, or he'll be writing a piece on what are estimating considerations on pod construction. We know, we're not. More than likely, highly likely, that they're not going to stick frame a moon base, right, or habitat. Can you imagine that? So it's pod construction. What are the things we have to think about in early cycles to understand constructability, and how do we estimate that early on instead of estimating it later on? Because of the complexity, the later we wait to estimate detail, the higher it's going to go. And we are at such a massive scale, it could double, triple, quadruple, because this is just so complex. That's why we need the detail. Robert Morelli with Turner Construction. They're an international construction company. His expertise is on general conditions, and as in the general contractors on this in this group understand the complexity and the challenges of estimating general conditions for any construction project. And again, we're always thinking of complex projects. A lot of us have hospital experience here. But we're also taking lessons learned from like fusion reactors and some projects like that, of what went wrong and why. All right, next are broken down into group authors, Dr. Bashish Singh, Dr. Jay Lunn, John Matatucci with Stantec, a worldwide architect and engineering firm, and Dr. Brad Hyatt we're writing, that group will be writing on a piece called Z-spin superposition for unit dynamics, articulation, and temporal prediction and comparable states. That's a lot. I could barely get it out of my mouth. But essentially, that is looking at unit costs in an infinite amount of ways and comparing different unit costs within an estimate. So every lens and every expertise can look at the master estimate or the estimate in all sorts of ways. And why that's relevant is because there's a lot of prediction and analysis that has to be created or understood. Anyway, so that's going to be an exciting paper. Next is Jay Lund, Dr. John Bolander joins the team. Dr. Gray Nearing, he's with Google, is one of their head research scientists. And also Dr. Young H. Kim is with the University of Louisiana, where that group will be writing an AI audit control judgment gate in complex sequence estimating analysis. So the reason this is important is because we all, the folks on the team, we all understand that there's a lot of information, a lot of analysis, a lot of predictive analysis, a lot of risk analysis, and a lot of breakdowns, even in unit. And I want to remind the team, remember, when we talk about unit, we're not on Earth, we don't count the screws. In lunar construction, we will not only have to count the screws, because some screws could be $10,000 because they have a very specific purpose. But not only will we count the screws, we will need to count how many times you turn the screw to get to a predicted specified state. And then it's still not a risk zero until the purpose and it's in a specified state and that system is working correctly. Then it's in an inert state and then goes into life cycle maintenance. But beyond that, it's still an active thing. So, but point being, if you can now think about the screw and break out and how massive this thing will be, AI is going to be used. It's just the way it is, and it needs to be, not to replace humans, but to make us think faster, make us go farther faster. But we don't want to lose control. So what this paper does is it breaks out something called a judgment gate, where we take complex analysis and we break it down into sequences, and very simple sequence with the end goal of a very complex, and it runs through a cycle. There's an analysis stage, an identification stage, a verification stage, and also an adjustment stage. And then once we understand that analysis, you go to cycle 2, sequence 3, sequence 4, sequence 5, until you get to your end state of analysis. So by the end, the team knows exactly what's going on and what AI did for you, and that we're in control. We're leading AI. AI is not leading us. It's going to be a fascinating a paper, I think. So,
hey, Paul, we got a question from Colin, and it kind of ties into something I was going to ask about as well. He asked how much of our focus should be given to specific lunar conditions. And one of the things that I know NASA was doing, there was, I think they were taking air monitors, if I recall, up to the space station this spring, or maybe it happened earlier in the summer. But they were going to take air monitors up that they were going to trial for like 7 months in the space station. But the goal of those was to be able to place those on the moon for air monitoring, for astronauts, et cetera, to understand what's going on there. So I think Colin's question is, it just led me to think about that. But what are we to do in terms of focusing on any of those conditions that are known or that we anticipate could be a part of the experience there?
Yeah, and I think step one, understand how do you set up the estimate? How do you maintain the estimate? How do you even approach it? It has to have a clearinghouse of solving problems. So step one is understanding that process, and we're on our way for that. Step two now is identification of means and methods and complexity. And so, I'll give you an example. As an example, staging. Well, if we just stage equipment, maybe some of the equipment doesn't necessarily need to be have environmental control, like air, but it needs maybe thermal. Maybe you have to then build some sort of a cover to protect it from radiation or heat, or whatever it is. And those type of means and methods they'll have to be figured out. An astronaut may need, to have a certain type of glove manufactured to hold a very specific type of wrench to put in a screw. You know, those are things that just have to be figured out. So to have the estimate articulated and matured in a way that it is a formatted, logical way, a clearinghouse of information. I think that what you just said about with this specifically, that's why general requirements is going to be so, and means and methods. It's going to be at a level that humanity really hasn't. Yeah, sure, they built the pyramids. That was pretty good. But there was air. All right. There was labor.
Yeah, and Steve added in the chat as well. Steve from NASA, who's been on calls with us, he's
Yes, Steve, right?
Great. Talked about the maintenance and repair at LSIC meetings. They've been talking about that and had some good discussions. He says he doesn't recall us bringing up yet the unique costs associated with lunar construction, how it differs from norms on Earth. Kind of does go into Colin's question a bit, and then it just he just brings up the cost of shipping and the cost of manufacture versus cost of labor, and just those modern norms that we know and that we've been taught. We have to throw those completely out the window.
That's why we have to think differently. Yeah.
Yes.
We literally have to think differently. Because if we don't, if it's estimated at 50 billion, or I'm throwing that out, prepare for it to be a trillion. If you don't go through the detail at the beginning, and the other thing, there's a couple things that are interesting is, and the paper goes through it, is we divide things into two sections and subsections. Pre-launch, which is mission, understanding the mission, and what the purpose is, technology, manufacturing, what have you, and then you have payload, right? So you have pre-launch, and as soon as the rocket ignites, then it goes into post-launch. At that point, remember, and then we have to deploy, stage, and execute, whatever that is, in pods or whatever it is. And some of it will be autonomous production, some of it will be astronaut, probably minimal astronaut, but there will be astronauts. Autonomous apparatus will fail and break and need to be fixed. And those are things that have to be addressed as well. To Steve's question specifically, he's absolutely right. And even that's part of return on investment as well. That's why we've dedicated in our suggestion of that coding structure, there's a segment in there for life cycle and maintenance cost that is coded to every line item. And those line items, that's why that Z-spin is so important at those, each of these units can be put together in systems, organized in systems that you can break down the cost of cycle, there's upfront costs, install costs, but then there's the long-term cost as well.
Yeah, Paul, I was actually more referring to just the whole theory, like here terrestrially, we've taken great advantage of automation and manufacture. Manufactured goods are just really, really cheap. It is cheaper to manufacture them across the globe and ship them than to try to make them locally. But when we start talking lunar, just the cost of shipping is astronomically expensive. It's in many cases orders of magnitude more than the component we're shipping itself. In fact, I would say it's probably always more. And that, how is that going to impact the approach that we take to design? And I think that impacts design more than it impacts cost estimation. But if we're trying to apply like our terrestrial corpus of knowledge and cost estimation, I think we're going to start to run into some of the problems with the assumptions we're making to work on Earth, but aren't the best option on the moon.
Yeah, I think it's a really valid point, and I think it warrants a section in the master paper. I think we have to. I think we, as thinkers, have to start with the premise of complexities here on Earth, and then take that and then convert everything to a moon construction project. We just have to put that cap on.
I think it may end up shifting us into a paradigm of designing for maintenance and repair.
Interesting.
Just the regolith is just incredibly abrasive and tends to wear and destroy everything. One of the examples was having like 3D printers on the moon that you're not necessarily manufacturing components, you're taking and you are putting the metal back on the lunar wheels that wore off during operation. That's not anything we would do here on Earth, but it's supposed to become really economical in the lunar situation. And we start to look at other things. And I mean, I campaign with the Lonely Maytag repairman. Nobody repairs their washing machine or their TV. It's cheaper to buy a new one. But you go to the moon, and all of a sudden, it's a lot cheaper to repair your TV with like a 2-gram component than it is to ship a new one up.
I think, Steve, I believe that the approach addresses this, and let me explain why I think, and I could be wrong, but I think it is covered, because when we estimate every line item, every unit, and I know this sounds daunting, but we do this to some degree on complex projects anyway. This is just to the extreme. Is for moon construction, because everything is so unique, we have to think all the way through. We just don't put a piece of equipment there and say, okay, well, it's X for manufacturing. We have to think through the entire cycle through simulations, and that is part of the code or the criteria of that line item, which would include that screw. Let's just keep that same methodology of the screw. We would have the design of the screw, technology of the screw, manufacturing of the screw, the payload of the screw, which includes, so everything up to payload, which includes transportation, everything, packing of the payload, which that costs something. So if that screw is, 2% of the payload, then it's 2% of the cost. Deployment, then its function, and once it's in its function, it's inert, but then it crosses over, again, part of the code of that line, just like a CSI, but on steroids. Construction, we have these construction codes, 3 different types that we use all the time. And so, but once it's in that place, then, and this is part of the theory, it does address this, it moves into a maintenance. And then also, and this is from the Department of Defense and Department of Navy, they also require demob. And we're using that example. We're following that. So every line item isn't just manufacturing and and installing. It's
Mobilizing.
everything. Yeah.
I think if I recall, and Steve would know more than any of us probably, but I want to say originally like it was around a $17 billion estimate or something for the International Space Station, just the construction. And obviously what they encountered is, of course, as Steve was saying, the cost of transporting the pieces became probably a lot more. But I think if you like apples to apples, it ended up being a $75 billion versus a $17 billion. So it just shows you we're dealing with something that hasn't been done, right? So we have no real gauge or benchmark or what have you. So it is a daunting task when it comes to that. But I mean, I think that there are probably lessons learned. I have one question before I want to make sure we go over some next steps. The LSIC meeting that happened in May, is there any information or things that were published from that should go in the Notion on the Notion site so that we can be up to speed on any new research or stuff that would inform our paper at the end of the day?
I can read, Steve. Did you go to the May? I registered to go, but then I had a conference. Patrick and I had a pre-construction advancement.
Yeah, NASA's travel policies have been changed, and I was unable to travel in May.
Okay. All right. Well, I think what we can do is we'll reach out to Jabu Abraham, who is our connection, and ask. I also think it's time that we present at a LSIC meeting, it wouldn't be me. I would want to go. I mean, it wouldn't be just me. I'd like to have a team go, do it. And so I think I'm gonna reach out to Jabu on that as well. Just to let them know where we are right now and their group, so there can be a little more synergy between the two, I think.
Yeah, I agree. I think this would be a great presentation, and that all the keynotes, all the big speakers were recorded and are online, so you can go and catch up. I attended a lot of them live virtually, but like the breakout groups and a lot of the live, literal live stuff, couldn't attend, and I couldn't find a hybrid option for.
Yeah. Okay. All right.
Yeah. So if Anne, I don't know what her bandwidth is, but if she could, I know she's on the call, saw her earlier. If Anne could help us with anything from that meeting in terms of getting it in on our Notion site, that may be helpful to everyone, just so we can keep up with what's going on, because the world is moving all around us, right?
Moving fast.
Yeah.
Okay.
Thank you, Anne. I really appreciate that. All right, next steps. If you remember, we put together a plan and a timeline. We're a little off on our timeline by a few months, but that's okay.
Sorry.
No, you're good, man. Is it too much to ask those who are going to be contributing to the paper? And I don't know about some of the groups, but there are some individuals on here, including myself, that are contributing. Is it too much to ask for us to complete our sections before the end of this month, by the end of this month, so that we can start collating those together? Because remember, the goal is for us to use the power of groupthink. We're going to have some facilitated sessions to really go through these different parts and pieces, larger and wider than this group. And that is going to give us the opportunity to get feedback on the parts of the paper and really refine it, hone it, make sure that it's going to take all of us together, the best minds in the world, to do this. So that's the idea. So I would say first, is there anyone on the call, and you would have to check with some of your other colleagues, Paul, but for this standpoint, is there anyone on the call that would have a problem finishing their section by the end of this month?
If I may, I'm going to speak for the Z-spin, infinite Z-spin, and the AI judgment gate sequencing. That's a greater work, and I think that's probably 3 months. Vishish and Brad Hyatt, Dr. Singh and Dr. Hyatt, what's your take on that for Z-spin and the sequence, AI sequence verification?
I can just speak for myself. I've got travel off and on the next 2 weeks, so getting it done by the end of the month may be a little bit challenging. But
No, those papers we cannot do by the end of the month. I'm thinking, are we talking maybe 2 months or 3 months or
Yeah.
longer? Because
Yeah.
those are major works. So
yeah, I mean, I was gonna say like, middle end of August is would be realistic for me.
yeah.
Okay.
So
And
let's
do
say
we-
end of August. Yeah. Vishesh, I'm sorry.
So, I mean, there'll be a separate paper, but I thought we will have an introduction of that topic in this paper as well. Is that still true?
Oh, I see. So you're splitting it down. So start with an introduction, move in. Maybe that's
I
the way
mean,
to do it.
just, yeah,
Introduce
introduce the
the
topic.
concept and then move deeper. Yeah. And you may want to do that, Jennifer Taylor. You may want to do that with cycle jumps because, introduce the concept and then maybe a deeper dive into it, because that is going to be a key part of just like the AI sequencing. That may be something that you want to consider. It's
Yeah,
major.
I can definitely have something by the end of the month. I mean, I had sort of put together everything I've written previously, and it's too long. And then Paul, you just sent me right? But not by a lot, but it's a few pages.
It's your stream of consciousness. And genius.
Exactly.
Yes.
But Paul, you sent me the draft of the paper, and just thinking through stuff today will help me tailor that a little, more for this. I think I can do that by the end of the month and get that some kind of draft into you guys.
Yeah, even if just a draft. And Jennifer, I'll send you the updated because I don't think you have the full draft. I think I gave you just kind of the general theory, but not in the master estimate flow. So
Okay.
I'll make sure you get that.
Okay.
Yeah, if we can do that and mid-August, that kind of thing, and then I know some of these will be introduced topics, which will be deeper papers, etc. But for the purpose of what we're trying to do, the goal now would be to organize and facilitate our sessions that we're going to have online. Which again, for those of you that haven't been on, that's something that we did with some papers that we did for the National Academy of Sciences. It worked really well. We were able to get a lot of good input. But you got to start with a baseline for people. And so that baseline will be the draft of the white paper. I'm thinking now between mid-September and mid-October would be when we would schedule those sessions. And it's likely to be 1 or 2 max, but it will allow us to use breakout rooms and other things. And we'll break it down. Now that Paul has broken down the sections, we'll probably look to break it down in that manner and assign people. I haven't decided on that yet, but that's the idea. Those are kind of our next steps in terms of where we're headed as a group. Do not forget as well, we still have the video. If you want to, if you know anyone or you or your companies want to sponsor that, get with Paul or myself. And remember, that is a Ted Danson. It's through Amazon Prime. They do but it's going to feature this effort. And so anyone that wants to be a part of that in terms of sponsorship, let Paul or I know, or both of us know. And we can clue you in as to how to get plugged into that effort as well. So I think we're at the hour now, and trying to respect everyone's time. Are there any other questions or comments, concerns, gripes? Whatever you have on your mind, we can take. Trust me. I really appreciate the attendance of everyone. We will be in touch on when our next section is. For those who are working on the sections, including myself, again, let's shoot for end of month, mid-August to get what we can get. It's a work in progress. And I think the idea Paul had too is this can become a living, breathing document as this journey goes. It's not going to stop. This will be our basis. And as we learn together, as we work together through the efforts of ELSIC and others who who are embedded in working through this. It will continue to be a work that ultimately we hopefully get to see within our lifetime, which I believe there's a chance of that, that this effort actually gets funded and begins in some way. So Steve, how do we participate as a contributor without being an author? John, great question. And that's exactly what I'm talking about. We're going to have facilitated sessions, which I said like mid-September, mid-October. You will be a contributor through those sessions or through your peer review. So either one, but we hope you can attend those sessions. They'll be facilitated. We'll have breakout rooms. Like I said, that was something that worked on 2 projects I did with National Academy of Sciences when we had a large group, and it really worked, and it made the effort much more credible, and it made it much better. So that's what we're planning. So John, I hope I answered your question. Yep. Thank you. All right. Everyone have a great weekend. Thank you, Paul. Thank you for all the work. Bishesh, and I think who else was on here? I saw.
Thank you,
he's gone.
Patrick, for facilitating. Yeah.
Yes, thank you all. I really appreciate
thanks,
it.
Patrick.
And Steve, thank you for continuing to be here from NASA. You've been a great. You're always on point and always giving us good feedback. So thank you.
Oh, and thank you for doing this. This is again fantastic for us to see. It's I think it's benefiting us all, and it's just frankly been really interesting discussion. So thank you for letting me participate.
Yes, sir. We appreciate you. All right. Thanks, everyone. Have a good weekend.
Bye.
Great.
Thank
Thanks,
you.
everyone.
Thanks.
Bye.
Take care.